All right, good morning. And this question is from the topic of kinematics, motion in straight line. The way we solve this problem is the first thing we notice in any question is, whether the velocity is constant or not. So, body number A, the velocity is constant. If you notice the body number B, it talks about the acceleration. So, it is at uniform acceleration. This will give you a large amount of hint as to how to solve this problem, right? So this is constant velocity, okay? It doesn't change. And this is uniform acceleration motion for car number B. So these are the two. So the first step you always do when you solve these problems is to identify the type of motion you're dealing with. You can watch my playlist on kinematics to understand every concept which you can think of, under the sun for kinematics. So this is the first step you always need to think about. So for car number B, you will always write the equations of uniform acceleration. Use that equation of uniform acceleration and make equations for B. Okay, this is a logic number one in your mind. What type of motion is being exhibited by the bodies? This is the only channel in the country which is giving you free physics education at the comfort of your home and giving you detailed explanation so that you really learn the topic and just not throwing solutions on your face. So let's read the question. This is all right. So let's discuss this question and see what's happening. So there are two cars you can see. One is the red car and the other is a green car. This is the starting point. Let me just draw the diagram. And these questions are very typical in the examination. Okay, so if the red car is driving at the speed of 20 kilometer per hour, it's a constant speed. The meeting point is 44.5 meters, if you see, and the total distance when they start the whole thing is 222 meters, right? So 220 meters, right? And of course, the meeting point is at a distance of, right? So let's find out. So this is the meeting point. It's around 44.5, right? 44.5. So if the red car is moving with 20, the meeting point is somewhere here, okay? This is just approximation. And if the velocity is 40, if the velocity of red car is 40, then the meeting point changes till some later point, okay? Here. And so this is it, and this is 76.6 meter. And then the velocity of red car here is how much? The velocity is 40 kilometers per hour, okay? When the meeting point is here. Makes sense? So you have two meeting points depending on the velocity you have. Meeting point number one, meeting point number two. So I'll just show the meeting point number two with this, okay? What are you supposed to find out? You're supposed to find out what is the velocity of the green car, right? That's your goal. You have to find the velocity of the green car. So let's start working on this. And it also says, the green car has constant acceleration, okay? So what is the significance of meeting point, right? What is the right? So this is the situation. The two cars are separated by 220 meters. In the situation number A, this car is able to reach here around 40 plus meters, and then this car already covers more distance. So obviously, it is mentioned that the green car is accelerating and the red car is uniform velocity. In the situation number two, let's get back to the initial position of 220 meters. The speed of car A is higher. It is at 40 kilometers per hour. So it covers more distance, right? 70 plus meters. And the other car, which is starting with the same initial velocity and the acceleration. So now they meet at 70 meters from the left hand side, right? So this is the situation. This situation is called as meeting point or the passing each other. In the question, you see the word they pass each other. Obviously, they are on different tracks, so they will pass each other. I hope the situation is clear. In both the situations, the total of the distance which they cover is 220 meter. Then that's what we need to do. Second thing we need to do is use that they travel through the same time amount, right? Left car, the red car is slow, so it covers less distance clearly, even if the speed is increased from 20 to 40. The green car is accelerating, moving very fast. So in the same time, it covers more distance. The point is, both the cars, have same time to travel the till the meeting point or when they pass through each other. If AB is the distance covered by red car and BC is the distance covered by the green car, this is a straight line, so distance will be equal to displacement. So AB plus BC is equal to 220 meter. Okay, and so this is the way you need to use this. Now let's focus on the point number A. Okay, this is the point number A. Let's only focus on this. So let's assume the green car has initial velocity. It starts with some initial velocity, which is u green. And let me use green color actually, u green. And because it accelerates, let the acceleration be a g. All right. Now the time which is elapsed is same, right? At the meeting point, both the cars have traveled for the same time but different distance. Okay, both the cars have traveled for same time but different distances. So let the time which elapses at the meeting point be t. So it is t for both the vehicles. Okay, now let me write down the equations. Okay, I have already told you the green car initial velocity and the constant acceleration is ag. All right, so let's use that concept. So at the first meeting point, which is A, let's write the equation for A. And this is the way you need to solve the numericals. First, you draw the diagrams, understand the picture clearly, and then find out the logic, and then start writing the equation. So let's talk about situation number A. So 20 kilometer per hour. Okay, so let me just write it as 20 into 1000, because I have to convert this, divided by 60 into 60. So this will convert this whole thing into meter per second, right? So this is around, if you delete this is 200 divided by 36 is equal to 100 by 18 is equal to 50 by 9 meter per second. So this is the velocity of the red car. So this is V red to start with. Okay, and let's start writing the equation for A. So the distance covered by the car number red is AB, right? This is the distance. So let me write the first meeting point, which is here. The equation for this, the total distance covered is 44.5 is equal to how much? The velocity, because the velocity of A is constant. Remember, this 20 kilometer per hour is a constant velocity into t. And the balance distance, which is 220 minus 44.5 coming from here, which is the distance traveled by the green car. So this is the displacement of the green car, okay, is equal to how much? We don't know its initial velocity, but it follows the second equation of motion. V is equal to u plus at and s is equal to ut plus half at square. So we will use s is equal to ut plus half at square. This is the initial velocity, time elapsed. So we don't know the initial velocity, right? We don't know the time elapsed. We don't know the acceleration, and t square, this is it, right? So this will be how much? Equation number 1 and equation number 2. So by the way, so we can find time from here. So time comes from the movement of car number red. T is equal to 9 into 44.5 divided by 50. And this, whatever it comes, okay, so 9 into 445 by 500. So this is the time that elapses. We will put the time in equation number 2 to solve it. All right, so we can get a variable equation in u and A. So this is equation number A, which gets used. In the second situation, which is B, the point number B, the distance covered is 76.6, but now the velocity is how much? 40 kilometers. So obviously it is double. So I'm going to write this as 100 by 9 into TB, the time it takes for red car to travel till B. So TB is equal to 76.6 into 9 divided by 100, right? This is the time it takes to reach B. Now use this time again. The red car follows the equation S is equal to UT plus half AT square, right? So S is how much now? Again 220 minus 76.6, the meeting point. Time we can find out. This is the time for B. So 220 minus 76.6 is equal to 100. Sorry, we don't know the velocity, the initial velocity of the red car, right? So we will write U red multiply by. This is the time we can calculate, and we will get an answer TB plus half A TB square. Make sense? Now we know the time. We have found another equation B, which connects U and A. So we can solve these two equations, two variables, and get the answer. All right. Just a quick word. You will be able to solve A and B and find out U and A for the car number second car, which is your green car, right? I hope that is clear to you. A quick word is a lot of questions pertaining to kinematics and motion in straight line are related to comparison of motion. Two bodies are always involved. An advanced way of this is, doing questions on relative motion. You can go to my playlist of kinematics and watch some numericals on the concept of relative velocity. So comparison can be done in a straightforward manner, the way we just did it, and also by doing the questions on relative velocity. So thank you very much for your time. I hope you enjoyed this video. Please don't forget to subscribe to my channel and give me your thumbs up. Thank you very much.